launching, so we're a little nervous, but also very excited for this day. We've been looking forward to it for a long time. We've had the privilege to guide 13 exciting deep tech companies through this accelerator that we launched in January. And so this is sort of the end and culmination of the program. Oh, of course, my presentation is freezing here now. Let's see, there, perfect. Oh, is anybody recording, by the way? Making sure, perfect, thanks. So yeah, my name is Nicole Forsberg, the Business Development Executive at Venture Partners at CU Boulder. Together with Justin, Tasso, and Emily here, we're the Ascent team. We've been running this accelerator. You'll be hearing from myself and from our team throughout these 2 days, so today and tomorrow. Very excited to do this, as I mentioned. Yeah, I want to start off by thanking our program sponsors, or program sponsor here at Colorado Office of Economic Development and International Trade, to make this possible. I don't know if we have Rama Harris in the audience today. I know she's a very busy woman, but a special thank you to her for making this partnership possible. So OEdit sponsoring and Venture Partners at CU Boulder were the one running this program. So thank you so much. And when it comes to today and tomorrow, I also want to thank Cushman & Wakefield, commercial real estate company, and Berg Hill Greenleaf and Ruscitti, sorry, I'm not good at Italian, law firm for your generosity to support our program and our companies today and tomorrow. We really appreciate it. So yeah, and I also want to say a very huge thank you for our fantastic mentors. So through these months since January, our teams have had the privilege to get some very sort of hands-on support by subject matter experts, entrepreneurs, executives in different areas, covering product development to finance to fundraising, productization, marketing, and PR. Just want to say a shout out to all of you. Without you, we wouldn't have had this program at the high level that it's been. So thank you so much. A lot of thank yous here. I also want to say we've had a very exciting curriculum through these past months. Here you can see the topics that we've touched, several different topics on this or several different sessions as well. As you can see, we've covered lots of legal stuff, the importance of growing a team, of course, one of the top things to think about when launching a company. So thank you so much, Dr. Ethan Mollick from the Wharton School, Julie Pearl and Cameron Bunt, who's also been mentors. We've talked about boards, product development, non-dilutive funding, and so forth. So thank you so much for your engagement with these companies and educating us on some crucial topics for success of companies. Really, just wanted to say a few things about Venture Partners at CU Boulder. For those of you that don't know us, many of you are very aware of what we do and who we are, but for those of you that are new, welcome. And just want to say, so Venture Partners, we were formerly the Technology Transfer Office, so that's a big part of what we do, but we have a much broader offering today, which is very exciting, which includes this Deep Tech Accelerator. So our mission is really to translate some groundbreaking research that come out of CU Boulder, the labs at CU Boulder, and turn these into businesses and commercialize them to make sure that we can solve some of society's most pressing problems. We have, as you will hear later on today, we have companies that are attacking some very big societal issues with some very exciting and advanced technology. So we're very fortunate to be active here in this space and support them. Just wanted to mention a few numbers so you get a little bit of an idea of the activity here. For those of you who are in Boulder, what's going on in the backyard. And yeah, so these are a few numbers from our previous financial year, 21. We launched, as you can see, 20 new companies, have several active companies in our portfolio right now. We're up to 171, I think was last week's numbers when we checked. Last year alone, our portfolio companies raised a significant amount of capital, $2.1 billion. And the circle to the right here, we have had several exits since we launched in 2004. As you can see, they've accumulated to a very large amount. So we're very excited for that. And that's really a big part of why we see that we need to continue to reinvest in new founders and new spin-off companies, because yeah, the numbers speak for themselves, but it's also very important to tackle some of society's biggest problems. So we're excited to do this. And so Ascent Deep Tech Accelerator is also one offering out of many different ones. So Venture Partners, we support sort of the founders from a very early stage. You can see to the left here, from the invention disclosure. And a principal investigator in a lab comes up with an invention, send us an invention disclosure, we look at it, then we manage sort of the intellectual property side, we support them in filing patents and managing that. First Look is a program where we incorporate our mentors to look at sort of a fresh out of the lab invention, and our mentors give them sort of warm first feedback to where this product or potential product could solve something on the market. And so it's very sort of early stage feedback. Then we have an extensive program block when it comes to customer discovery. So NSF I-Corps, many of you might be aware of that. It's the National Science Foundation's sort of commercialization arm or a program, which is focused on very early stage customer discovery, making sure that you find or identify product market fit and that your invention really solves an actual problem, somebody's willing to pay for it and so forth. And then comes in Ascent Deep Tech Accelerated, which is really for companies that have gone through this extensive customer discovery phase where they have found product market fit and they're now ready to sort of take the next step into forming a company. So as you could see previous with the topics we touched upon, there are sort of all the different aspects of really launching a company. So this was a missing piece that we identified. So we're really happy that we're being able to do this now. And then in the black hexagons here are the various support programs for non-dilutive funding. We have the Lab Venture Challenge every year at CU Boulder, New Venture Challenge, Center for Translational Research, which is a support center to help founders identify SBIR opportunities or NSF opportunities, any sort of government related non-dilutive funding. Important to sort of chase that money as well, especially because we're working with deep tech. There's not a whole lot of patient capital on the market. So it's important to have this as a support as well. And then the last phase, of course, which we're excited to sort of send our companies into now, is for the investment stage, where we recently launched our own Buff Gold Ventures. It's a venture capital firm standing alone that invests in CU Boulder spinoffs. So that's really exciting as well. I thought I'd mention just a few. We've actually had an exciting year. 5 exits this past financial year, and as you can see on the slides here, the principal investigators, the researchers at CU Boulder are mentioned here, and the different companies. Myocardia, for instance, so you see they were acquired by BMS for $13.1 billion. It's a precision cardiovascular medicine company. Leslie Langwald running that, and we have SomaLogic as well. You might have heard there are lots of buzz about them lately. They're protein biomarker discovery and clinical diagnostics company. Then we have Solid Power, recently went public as well with Sihi Lee and Conrad Stolt inventing that. They're an electrical vehicle battery company. And then we have MedShape, foot and ankle surgery space, exciting company as well. So you can see it's very, a broad range of technologies here, from automotive to medicine. Right. So with that, hopefully you got a little bit of a background about Venture Partners, the program, I'll just hand it off to my colleague Justin here to walk you through the rest of the day, where we'll get into some exciting pitches here. So thank you so much from me.
Thanks for wrapping that up, Nicole, and introducing us. You came in right on the minute, so congratulations. So we're gonna get started with our pitches here shortly. But first, we wanted to give an opportunity to highlight a really interesting organization called Pledge 1% Colorado, and we have Matt Zweibel here, and we're gonna let him take a few minutes and talk to us about what Pledge 1% is. So if we can just, I don't know if Matt, do you have a slide that you would like to share, or?
No, you can keep it on this. That's more than fine.
Okay, thank you.
Thank you.
Well, thank you to the Venture Partners team for giving us a few minutes. I don't think I need all 10, so hopefully I can give you a few minutes of buffer time to get back. As the slide says, my name is Matt Zweibel. I am the director of Pledge 1% Colorado. We are an organization that was started here in Boulder back in 2008. One of our first companies was Rally Software, who many of you may know. They set aside 1% of equity in the business right after their Series A. And it was all really inspired by a little company called Salesforce. So back in 1999, Mark Benioff had this big, bold idea to set aside 1% of Salesforce to be earmarked for the nonprofit sector. He saw the Bay Area was changing and wanted to make sure that as he grew and scaled his company, that the community around him was also bettered at the same time. Rally, and specifically their CTO, Ryan Martins, who some of you may know, had a very similar idea. And so they took this little idea from the Bay Area and took it to Boulder, where they, like I mentioned, set aside 1% of equity. Upon IPO, that 1% turned into $1.4 million that was spread to nonprofits up and down the Front Range. I was really appreciating some conversations that we had early with the Venture Partners team just about these big, bold ideas that are really trying to tackle some of society's biggest issues. And I think in parallel, those beautiful technology companies can actually make the community better at the same time. So it's a really sort of cyclical opportunity to support the community along with building a great business. So I'll drop my email and our website in the chat after this. I think it's a really phenomenal opportunity for any company to get involved. If there are investors or other folks that have portfolio companies that are interested in potentially taking a look at this, I'm ready and willing to chat. So thank you very much to the Venture Partners team, and I'm looking forward to the rest of the pitches today.
Thank you so much, Matt. Exciting. I think Justin is talking and he's
I didn't realize I was on mute, but yeah, thank you, Matt. And that's something, community involvement and giving back, that's something, core to what we're after here at Venture Partners. So we encourage all of our founders to consider making that pledge. Like Matt said, it can really add up and it can make a difference. And to you now, it doesn't actively cost you anything. I mean, it does cost something in the future, but not actively at this moment. So with that, we are going to get started with our pitches. And up first, we have Saurus Lifting. We have Dustin with Saurus Lifting, and this is an exciting exciting company in the construction software space. So with that, I will have Nicole stop sharing her screen and let Dustin take it from here.
Thanks, Justin. Excuse me. Thanks, everyone. And thanks to the Ascent Accelerator for a really awesome 4 months. I learned a tremendous amount.
Thank you, Dustin.
Give me a thumbs up when you've got it.
Everything looks good.
Sweet. Time is money. Safety first. These are mantras on the construction site. I know this because my dad's worked in construction his whole life, making me constantly aware of the problems faced by men and women in this field. And these problems can be boiled down to a couple of troubling statistics. Construction workers are 3 times more likely to die at work than the average US worker. And poor safety goes hand in hand with poor productivity, something that's costing the construction industry almost over $1.5 trillion every single year. At the core of this problem is the fact that once a project breaks ground, job site logistics get messy quickly. Today, I'm going to introduce to you how we are building a smarter and more flexible planning tool for one of the most dangerous, one of the most expensive, and one of the most logistically challenging pieces of equipment on any construction site. The crane, the backbone of any major project. These machines rely on careful planning to do their job safely, as is evidenced by the fact that almost 40% of crane accidents were a result of poor planning. To understand this problem deeper, let's take a look at the current workflow for crane companies when they prepare for one of these big lifts. Crane companies rely on a bunch of disjointed software that doesn't talk to each other. They rely on note-taking, eyeballing, and handwritten notes in order to piece together a comprehensive lift plan. As a result, numerous people end up burning hours of time, even for a basic lift, just developing static documentation that doesn't do anyone any good. My point is, it's not easy, and safety should be easy. That's why we built LiftPro, the first comprehensive lift planning solution. With LiftPro, we empower our customers to cut their planning time in half while making the entire job site significantly safer. Let me step you through how this software works. First, our mobile-friendly web app replaces note-taking and pacing off of dimensions during the initial job walk. Next, a lift planner or project engineer can add more detail to the plan, such as rigging design, crane selection, and operator certifications. An optional 3-dimensional simulation can be included to clearly communicate how the lift should play out. Finally, when the plan is done, it can be electronically circulated for approvals. When the crane is mobilized, the operator and his or her team will have a mobile-friendly lift plan detailing every step in the process. With a mobile-friendly tool, automated calculations, and a collaborative workflow, we're going to save our customers $300 on every single thing that they pick up. This doesn't include the cost of accidents avoided and project delays due to miscommunication and poor planning, something that quickly becomes tens of thousands, hundreds of thousands, or even millions of dollars on a busy construction site overnight. We're well on our way. We have 5 letters of intent from crane companies who are using a basic version of LiftPro right now. But we're not just stopping at lift planning. Domestically, this is about a $600 million market. Globally, there's a rapidly growing, massive construction market in need of better lift planning tools. On the way to this $5 billion opportunity, there are opportunities to streamline job site logistics in a broader sense for the whole construction site, or to sell data and analytics into the commercial construction insurance market. We're backed by some fantastic advisors with tons of experience in construction and entrepreneurship. Sean McCranor is a venture-backed construction technology founder based right here in Denver. Jim McGibney has run multiple large-scale commercial and industrial construction projects here in Colorado. Chris Gustafson has founded a construction company and now runs innovation and entrepreneurship for the University of Colorado. And David White is also a construction tech founder, building advanced monitoring systems for heavy equipment. Like I said, I've been around construction my whole life, and I worked a few different jobs in this industry while I was getting my degree in electrical and computer engineering. I'm joined by Eric Heinmiller, founding software engineer with years of experience leading technical teams and building full stack web apps from scratch. Today, I'm raising $400K with less than a third of allocation left in this round. I want to meet with investors who are excited about the future of construction technology and passionate about making a difference in the lives of the people who build our world. I'm here today because construction is not as safe as it should be. We are on a mission to make safety easy for the construction industry because it shouldn't be hard to survive a day at work. I'm inviting you to join us. Thank you.
Yep. Thank you, Dustin. Just like to open it up to questions for anyone. I mean, we have 15 minutes still, so before we're back on time. So, okay, well, Dustin, so we have a question from Bill Jeffrey here. What is the competition and your competitive barrier to entry?
Yeah, so initially, we are competing directly with a company called 3D Lift Plan based out of Florida. They're kind of the standard for lift planning right now in the United States. However, directly from customers, I've been told it's frustrating to use because it requires significant amount of training. So typically they have trouble getting newcomers to the industry to actually use it. And it also doesn't work on mobile, which if you know anything about construction, they're walking around in the field all day. They need something that they can have on their phone. That's kind of the standard now. That is our moat initially. But as we go further, we plan to collect data on operators so we can run analytics on them, and then we'll create kind of a data moat around our platform versus 3D Lift Plan.
Okay, so we had another question here from Joey Money. Are you proposing a software as a service model, and do you have revenue projections?
Yeah, that's exactly what we're doing. And let me just show you the pricing model here. Sorry, I got too many windows open. Here's the pricing model. We go from $1,000 for a small business owner operator, kind of an independent contractor, up to $30,000 annually for an enterprise customer. There's also add-ons for the 3D structures, like the 3D simulation I showed, as well as adding additional capacity to your account to do more plans. And in terms of revenue projections, we're looking at about 400 customers by 2025, right around the $12 million annual revenue space for just Lift Pro, this product.
Okay, we had another question from Tim Jones, who was wondering more about the raise. What milestones will be accomplished, and what are the terms of the deal?
Yeah, great question. So the milestones that we're going to accomplish with this kind of pre-seed angel round will be recurring revenue with 5 to 10 initial customers. These are customers we already have a relationship with, and we want to hit product market fit really well with them before we go to growth. That's the big milestone for this raise. And to do that, it'll primarily pay for team development is really the big cost for us. And the second part of your question, the terms of the deal, $5 million post money valuation cap on a safe 20% discount rate.
Okay, I am not seeing any other questions in the chat. If you have any other questions for Dustin, please get those in the chat for us. And also, if you come up with anything later, feel free to message me personally or Dustin personally in the chat, or email Emily, Nicole, or myself at a later date. Okay, I think with that, Dustin, if you have any other closing remarks, I think we're going to move on to the next team then.
No, just a big thank you for the whole Boulder entrepreneurial community, Boulder, Denver. Fantastic group of people. I've been honored to be a part of this. So thank you.
Great. Appreciate you presenting today. So, all righty. Okay, moving along with our schedule. Next, we have Human Fusions. So Human Fusions was founded by Jacob Siegel, and they are commercializing some haptic glove technology. So I will kick it over to Jacob now.
Hi, everyone. Thanks for having me. I am Jacob Siegel, founder and CEO of Human Fusions Technology Corporation. We are here to power the feeling of touch in the digital world, and we're happy to present our progress to you here today. So our digital realms that we are experiencing right now through Zoom are lacking a critical sense touch. Right now, all that we get from digital entertainment like games, movies, television are sensory. The sensory information we're getting are only for our eyes and our ears, auditory and visual information. In the future, to allow for a sense of immersion or presence or embodiment in our digital realms, we need to add a third dimension, a third sensation, and that is tactile information. The devices that provide tactile sensations need to be transparent, mobile, and ubiquitous. These ideas aren't new. This is straight out of science fiction, right? We've seen these ideas across right, Ready Player One and other popular science fiction sort of mediums. But the fact is that the technology available today to build these things are in its infancy. To be transparent means that you're not noticing that it's there, right? That the wearable system isn't noticed, just like what we have today, like our rings and our watches, we can wear for 12 hours throughout the day without directly noticing that they're there. Also that they're mobile. They go throughout our daily lives without limitations. This has not been available before in this space either. And they're ubiquitous. That means they can apply to all these different digital realms, including augmented reality, where you're still interacting with the physical world around you, as well as virtual reality, where you're immersed inside of a 3D environment, so on and so forth. If we can solve these three problems, then I think we can get there. We can get to widespread tactile interfaces so that your digital and entertainment products can be sensed in it through this tactile channel and create more immersion. Everyone out there is doing this, right? Meta, formerly Facebook, is developing their haptic glove. Haptics with an X at the end is a startup company also in this space that are effectively using haptic systems. That means they're robotic. That means they have motors, they have pumps, they have moving parts that press on your skin in order to create illusions, right, of digital objects interacting with your body. These are typically, right, they're going to be bulky, they're going to be tethered. So that means you have to wear a pump like this woman on the right on your back, or you have wires or tubing coming off of you like the woman on the left. And they're not applicable to the overall goal of creating immersive environments that are ubiquitous across a mobile environment or an augmented reality environment. So what we're doing, right, is using direct neural stimulation. My background is in prosthetic limb design. My co-founder, Dustin Tyler, is an expert in neural interfaces. This is how we plug into the body and create perceptions of things that aren't present. All of our core technology creates tactile sensation through direct neural stimulation. That means we're sending electricity into the body to interface to our electrical systems in our intact limbs. Our peripheral nerves are wires effectively that connect the sensors in our skin to our somatosensory cortex in the brain. In other words, we're hacking the body. We're plugging into the electrical systems that are already there so that we can create perceptions of things that aren't. And we've done this before, right? First in prosthetics, we have amputees who can feel the hand that they don't have through similar technology. And now we're leveraging that know-how to create this mobile and wearable device. So our product roadmap is the following. Today, we're raising a pre-seed round that'll allow us to incorporate the company, and I'll tell you more about that raise here in a minute. Then we have then we create a fingerless glove prototype. This product, right, is going to target the console, mobile, 2D and 3D gaming sector. The major players in this space are like the game engines like Unity, as well as the mobile developers like Niantic, who created, of course, Pokemon Go. We think that we can plug in there first because gaming, right? One, it's a massive market, right? It's bigger than Hollywood, and two, they tend to be early adopters of new technology. And finally, they have digital information that we can use. That means the interaction the interaction physics that's going on inside of those games, we can plug into, pull out that information and stream it to our wearable. Then we want to be positioned later, starting in 2024, when we raise our Series A, to be ready for the adoption of augmented reality headsets coming out of all of our big tech players. So this means when Apple or Google releases augmented reality glasses so that you can see your text messages up here, or you can turn up the volume on a remote speaker with a digital knob over here, that we can provide mechanical integrity to those digital objects. That's where we want to be come 2024. Then we also have research and development to create a minimally invasive system. So that means we actually give you a shot. We implant a haptic system next to your median nerve in your wrist, and then everything around you can be haptic going into the future. This has interest. We're seeing interest in that realm from our academic funders like DARPA and other defense-related ideas. So at first, our business model will be a device and subscription model. We will sell the system, the hardware good. That'll be a $300 to $400 product. It'll be a luxury good, right, in the gaming sector. But of course, we see price points for similar technologies getting plenty of traction, right? Meta's Oculus headset, that's the latest VR headset technology that's come out, is at a price point of $300, and it's been sold, more than any other device that's come out on the market in this space. So we sell those systems for initial cost, and then we have a subscription model to provide enhanced features like calibration routines. Then we add on new gaming content over time for those subscription holders, and we create recurring revenue in that manner. Then as we get more, as we scale our user base, we can seek out software licensing revenues from game engines, game studios, and movie studios going forward. The hope there, right, is that we create new content where there's more tactile information streaming through the game or the movie, so that the experience is even more immersive or more entertaining to those consumers. An example in this field is when Meta acquired Control Labs for $1 billion. Control Labs was a feed-forward neural interface. That means they were taking data from the human and sending it to the computer. We are effectively doing the opposite. We're neuroscientists just like them, and what we're doing is taking data from the computer and sending it back into the body. We think that this feedback value proposition has even greater worth than the feed-forward control systems that Control Labs was doing. They were worth $1 billion in 2019. I don't know what we will be worth, but it's indicating the need from the big tech companies for human computer interaction and for the value that they see technologies in this space providing to their business models. So myself and Dustin Tyler are forming this company now, today.
I think we lost you, Jacob. Screen froze. See if we get him back.
What an unfortunate time to lose your internet connection, right on your last slide.
Yeah.
Can s-
Let's see if we get him back in just a minute.
Yeah, I think he noticed, and he's. Oh, is he back? There, he's
Sorry,
back.
everyone.
No problem.
That was dramatic.
Yeah.
Where did I lose you all?
Just on the team slide. And
Okay, good.
thankfully, we have a few minutes of buffer, so it shouldn't be an issue.
I apologize. I don't know what happened there. I was describing Dustin's experience, right? So he's a internationally known scientist in neural interfaces. Effectively, we're leveraging his more than 20-year career in how to interface to the peripheral nervous system, how to stimulate nerves so it creates perception and not just electrocution. And we're leveraging that technology. We're licensing it out of Case Western Reserve University, where he spent his career, to create the foundational IP for our company. So with that, we're raising our pre-seed round to meet these 3 milestones. First is the fingerless glove prototype. So we have an academic prototype. We've done this with in an academic setting, but then we need to create a mobile system that could be taken around the world, shown off to people, and worn by everyone across the board. We also need the Unity-based gaming plugin. So this is effectively our interface between our system and the gaming or entertainment content we're going to be relating to. We'll be developing an API and basically a command structure so that we can talk between those two systems. And then we're going to create our own in-house demos. So this is we're going to create examples of the way developers could be using our technology. So that means 2, 3, 4 minute gameplay exercises where you're a character in the game and you're feeling all the different interactions throughout the gameplay, as well as more pragmatic examples like just an augmented reality demonstration, right? Where the digital objects around you have mechanical integrity, where you could feel the volume knob as you click and turn it up, or so on and so forth. A virtual keyboard, right? So when you type in a virtual space, you can feel the clicks of each keyboard stroke. Those ideas is what we're going to be developing. We're raising 1.5 million for 18 months of runway, and we're happy to say today that we have that we'll be signing a term sheet with Convoy Ventures here possibly later today. Where we effectively join hands with them. They're a Denver-based gaming-centric early stage venture capital firm. They'll be leading this round and of course advising us, helping us get further into this field of gaming. We have 250,000 remaining in the round. We're happy to chat with anyone here about that, those terms, and provide more details there on a one-on-one basis. So with that. Thanks for the time. Sorry about the crash of my computer, and happy to take any questions you may have. It's been wonderful to be with you all today and the Ascent program over the past semester. Thank you all.
Yeah, thank you, Jacob. Super exciting technology. So we do have a few questions in the chat now. One of them I think you covered kind of at the end, but I'll still ask it. Has this product launched yet, or is it still being developed?
Good. We certainly have not launched the product. We have academic prototypes, and I can share videos and other content on those things if anyone's interested. It's effectively we have one-off prototypes at this point. This pre-seed round will get us to single-digit units. We'll call it like 10 units of the prototype that I can send around and go meet with people and show it off. And then we will raise a full seed round. We're targeting a year from now, where we'll scale that manufacturing. We'll effectively create thousands of units to get it into early adopters in the gaming space.
Okay, we had a question here from Susan. How does a fingerless glove cause the fingertips to sense touch? Does the implant suggest ability to sense haptic touch anywhere on the body?
That's great. Thanks, Susan. Here's the fun part. we're tapping into the nerves, right, that are innervating your fingers. So when I press on my fingertip, I'm creating right, the sensors in my skin, the mechanoreceptors are creating action potentials. That's electrical signaling that goes down the finger towards the brain. We're putting our devices, we're intercepting that signal in between the fingertip and the brain. We're injecting it with our own stimulation. All of those ideas are stemming from work in prosthetics. That's how we do it with somebody who has amputation, right? They've lost their hand, but the wires are still there. So if we send electricity, or basically if we send information into those wires, into those nerves, the brain can perceive them as sensation that used to be on the fingers. And so without going further into the neurophysiology, that is how we're doing. Happy to talk more about it. It's obviously what I like to do. And here's the company that we're going to use to spin it out to able-bodied, you and me, so that we can feel things that aren't there.
Okay, so we have one more two more technology questions and two finance questions, and then you've got about 3 minutes left. So just to give you some timing on that. One quick one, how did you decide between Unity versus Unreal or other gaming engines?
Good, we haven't decided. Unity is where we've started. And so, there are Unity and Unreal are the two biggest gaming engines. I'm sure we'll develop, we will need to be able to interface the both eventually. We've started with Unity because we have the best contacts and the best people, the best relationships there.
Great. The next technology question is, what kind of training is required for the human, and how long until the haptic feedback feels natural? In particular, as you get to the ring or the implant level, how do you differentiate specific haptic feel? Yeah, go ahead. Sorry.
I won't be able to answer all those things. Here's a quick version. Today, it doesn't feel like the coffee cup in front of you. But what we're planning to, what we need to do is develop out, or we're basically translating what we've been able to do with the amputees, which does feel like pressure, into this wearable technology. So it's open space for us to do the R&D, and our core IP that we're licensing are those techniques. It's the patterning of the stimulation to get to those different sensations and to make things feel more natural. So we're not there yet, but that is where we're going. And I guess I'll have to stop there for that one.
Yep. Okay, that was coming from Bill Jeffrey, by the way. Tim Jones would like to know, have the licensing terms been negotiated? And if so, what are the high level terms?
Good, yeah. So we've been negotiating those for a while now. We'll have an exclusive option agreement signed here within weeks. The high level terms on that option agreement have to do with the IP that we have an option to, as well as the timeline that we have to explore it. I can share more of that information on a one-on-one basis. We're going to pay some upfront fee to get that option, and then we'll negotiate a full license in the months ahead after we get access to that technology. Happy to talk that over, Tim, whenever you like.
Okay, and then one last question to finish up here. What team members will you need to add to meet your objectives over the next 18 months? Does that include sales?
Good. Short, no on the sales item, right? We're not going to market within these first 18 months. We're doing all internal R&D to get ready for that. Three hires that we have planned for this first raise are a director of product who's doing a wearable designer, right? So the textiles, fabrics that we need to interface to the body. We have an embedded electronics engineer, right, to miniaturize our systems to get them into a mobile form factor. And we have a game developer. That's a computer scientist who's going to be interfacing to the game engines, creating our demos and building out those resources for future content developers.
Great. Thank you, Jacob. And if anyone else has any questions, feel free to direct message Jacob or get in touch with Emily, Nicole, or myself, and we will pass those along. So, yeah, no, great job, Jacob. Very interesting. I'm gonna hold off on just jumping back and forth into the slide deck and just introduce our our next team. This is Polaris Electro Optics. They are an electro-optic photonics company. And they have a really interesting technology, very, very cool science, very cool company. So with that, I'm gonna kick it over to Matt and let him get started on that pitch.
Let's see. Okay, everyone hear me okay? And can you see my screen? Okay, great. Well, it's a pleasure to be here. My name's Matt Glazer. I'm one of 5 co-founders of Polaris Electro-Optics. Polaris was founded 10 months ago to commercialize technology developed in our research labs at CU Boulder. And I'll tell you a little bit more about what we're trying to do. I guess it's safe to say that no one will be surprised when I tell you that the amount of data streaming over the internet is increasing exponentially over time. This plot basically shows that the volume of data traffic is doubling every year. This information tsunami is driving a growing demand for devices that can transmit data over the internet more quickly at a lower price and with lower power consumption. And so meeting this demand is something that we're focusing on, as it will require the new materials platforms and technologies that we bring. So where's the bottleneck here? Well, there's a device that's a component of the transceivers that transmit data over the internet called an electro-optic modulator. This device is really the beating heart of the internet, because it's what converts electrical data into optical data, which is necessary for putting data over fiber optic cables and for high bandwidth communications. At the heart of the modulator is electro-optic material that makes this conversion from electrical to optical signals. But the problem here is that the current electro-optic materials are too slow, too expensive, and too power intensive to meet the demands for data movement that we anticipate in the near future. So where do we come in? Well, in June of 2020, our group at CU Boulder discovered a new family of nearly ideal electro-optic materials called ferroelectric pneumatic liquid crystals. This discovery was recognized by Physics World as a top 10 breakthrough in physics for 2020. And what's special about these materials is that they combine the favorable properties of liquid crystals with those of high polarization ferroelectrics. And this combination is where the key may lie to solving these data transmission problems that we anticipate in the future. So what does the competition look like here? Well, as it turns out, the competition actually is quite strong in this field, because this need for higher speed, higher efficiency devices is well recognized. And so there's a number of competing technologies. I'm just mentioning 2 here, which are technologies based on either crystalline ferroelectrics or electro-optic polymers. And in this space, there are a number of startup companies that are competing for a share of this electro-optic modulator market, utilizing these materials as the basis of electro-optic modulators. However, there are shortcomings of these approaches that we believe we can circumvent. And key among those are thermodynamic stability and ease of integration of our materials into existing silicon CMOS platforms, which leads to low cost of fabrication. We also have a strong IP portfolio covering our materials and their applications. And it's interesting to note that one of these startup companies called Lightwave Logic is based in Colorado and publicly traded, developing devices based on electro-optic polymers. And even though this is a pre-revenue company, its market capitalization is close to $1 billion, which is remarkable and illustrates the value of this marketplace that's perceived by investors. So our technology broadly is applicable to the $1 trillion photonics market, but we've decided to focus on the narrower photonic integrated circuit market. These are devices that integrate multiple photonic devices on a single chip. And this is a sizable market, has been growing rapidly in recent years and projected to grow rapidly in the future. And we plan to partner with silicon photonics foundries to produce electro-optic components that will be easily adapted into the manufacturing processes of silicon photonic circuits. And if we estimate, based on estimates, that we can capture, that our components could account for 15% of revenue for these integrated circuits, then we can project that in 2025, our revenues may be in the neighborhood of 80 million per year if we can capture around 3% of this market. And these figures are based on PE multiples and margins from photonics companies that are publicly traded. Okay, so it's early days for us. We were founded 10 months ago. And so we're working right now on non-dilutive funding and looking to raise more non-dilutive funding. But we've already substantially de-risked some aspects of this technology, one of which is to develop appropriate materials that can operate at room temperature and can be easily integrated into electro-optic modulator devices. We're currently working with several collaborators, potential strategic partners, to develop benchtop prototypes to demonstrate the potential of this approach. And if we're successful here, then we'll be looking to raise significant private funding near the beginning of 2023. That will allow us to build and evaluate high-speed prototype devices. And in this timeline, there's certain milestones. We expect that we may be able to raise some initial revenue as early as 2024, but key benchmarks will be to engage with small volume and large volume foundries to develop modulator process design kits incorporating our technology. And we will continue to essentially collaborate with academic groups at CU Boulder to generate IP and explore new materials for these applications. So our team brings a strong science experience extending over many years. Basically, there are 4 of us are professors at CU Boulder, and Corey Pekanovsky is a photonics industry veteran who's our CEO. I didn't show that on this slide, but we collectively have many years of experience in relevant technical fields, and some of the founders have in the past founded successful commercial efforts, including DisplayTech, a display company that was founded by Clark and Walba, and Instec, an instrumentation company founded by Clark and McLennan. We also have a outstanding advisory board, including Ted Waverka, Mark Newhouse, and Zach Antovich, who are industry leaders and entrepreneurs with many years of collective experience among them. So with that, I'll conclude. And I wanted to thank the Ascent organizers, mentors, and participants for all their help over the past few months. And I thank you all for listening to our story.
Virtual applause.
Yeah, no, thank you, Matt. That was great. So let's see here. We have a question from Ian McLaughlin, and he says, I assume that this will require specialized materials. How and where are these sourced, and are there current supply chain challenges?
Right, that's a good question. So till now, we've either synthesized materials we need in our own labs or outsourced the synthesis to contract synthesis houses. Down the road, we may partner with larger chemical companies who may help us with the supply chain here. There were setbacks with COVID, but we actually have not had severe problems in sourcing materials over the past year or so. But a key aspect of this is materials design. So that's really our specialty. And so we've basically, these are organic materials. Then you can formulate mixtures of these materials to optimize the properties. And that's more or less the workflow for materials development.
Thanks. We have another question here in the chat, and it is just to clarify, are you looking to raise 125K pre-seed this round?
No, we're holding off before looking for larger investment. The 125K we already have in hand from the state of Colorado. And then we've applied for SBIR funding back at the beginning of the year and are waiting to hear about that.
I just don't have anything.
But because we're sort of at this stage where we don't have a working
I don't have 3 things tomorrow.
prototype,
Can everyone please mute their mic?
then we think it's premature to be seeking major investment at this point. I think we have a lot of interest. We've talked to a lot of people who are quite interested in this, but everyone, rightly so, wants to see a prototype that demonstrates the viability of the technology. And so that's the job of the next few months, possibly to the end of the year, is to really, really demonstrate that this works.
Okay. Just to summarize that, it's that the 125K that you're not looking for that currently. You're looking to build the relationships that you're going to need in the future after you de-risk this initial prototype.
That's right. I mean, I guess we're just sort of showing up on the radar screen, but we don't have an ask right now, but check back with us early 2023. Okay. And we, see where we're at that point. And we will be interested in talking once we feel that we have something really concrete to offer.
Okay, I just have one more question. Could you elaborate more on your strategic partners and how you're going to develop this initial prototype and present it to these small volume foundries if you were successful?
Right. So currently we're collaborating with 4 different groups around the world who are really some of the top groups in the photonic integrated circuit sort of world. And we're supplying them with materials and expertise in handling those materials and integrating them. They have the expertise in the photonic devices side and evaluation. And so this is our sort of initial sort of stage, is to just get a minimum viable prototype, I guess, in collaboration with these groups. If we're successful there, then we'll work on establishing relations with small volume foundries, and several of our strategic partners or potential strategic partners already have those relationships in place. So we're going to leverage these connections with these collaborators who share our interest in developing this technology. So that's more or less the plan. Did that answer the question?
Yeah, no, that was great. We are out of time, so I'm going to cut you off there. Thank you for presenting, and very exciting technology, and hopefully there's people in the audience that are gonna be here to help you bring that to market.
Right. Thank you, everyone.
Yep. Okay. moving along, we have seedling biosystems up next. Very interesting. Biomanufacturing. Thank you. It's yeah, hard to put it into one word. So I will kick it off to them.
Oh, great. Thanks. So hi, I'm Brian Decker, and I'm professor of molecular biology here at the University of Colorado and founder of Seedling Biosystems. So I come from a long line of farmers actually in the Midwest, and I'm going to tell you today how we are combining the worlds of molecular biology with farming to sustainably manufacture important chemistries. Okay, so nature is the ultimate chemist, and most therapies actually come from natural sources, and they're known as natural products. So for instance, squalene is an important additive for vaccines, and it's extracted from sharks, all right?
Hey, Brian.
Yeah?
I'm sorry, I don't mean to cut you off, but your slides are not showing fully.
Oh, can you see it now?
Yes, that's better.
Okay.
Thank you.
Great. All right, yeah, thanks. So where was I? Yeah, so taxodyne. Taxodyne is a precursor of very important chemotherapeutic called Taxol. And it's actually collected from endangered yew trees, right? And the cannabis plant, well, as you well know, that produces a myriad of important compounds, including cannabinoids and terpenes. So, okay, so what's the problem? Well, yeah, just ask the sharks, right? And even cannabis is a finicky plant. It's not easily farmed. For instance, look at the high wattage needed here to make these plants happy, right? Well, okay, so seedling has a solution. What we're doing is we're taking the genetic instructions to build these natural products from their original sources, right? And we're actually going to transfer them to the soybean plant, okay? So let's like squalene, for instance, here. It's actually found naturally in soybeans, but in trace amounts. And what we're going to do is we're going to bring those levels up to shark levels, right? Oh, and I want to point out here that the farmer in this picture is perfectly safe. He has no chance of being bitten or attacked by these plants, right? Okay, so why soybeans? Well, soybeans were first domesticated in China and have been bred for over 9,000 years to be extremely resource efficient, right? Like, okay, so for instance, my grandparents, they would not have considered themselves counterculture environmentalists, right? But they certainly knew how to keep every expense and natural resource that they used to an absolute minimum when farming their soybeans. Oh, well, there we go. Okay, so how's this going to work? Okay, let's take that other example, cannabinoids. We'll contract farmers that are premium to grow and harvest our soybeans, just as my grandparents did, right? And with the seedling method, the plants will not produce the cannabinoid in the field, right? The plants will contain the genetic instructions to produce a cannabinoid, but will not be switched on to do so. Okay, so then the soybeans will be dried and shipped to our facility here in Colorado. And then the beans can either be stored for years or used immediately by turning on the genetic instructions to produce the specific cannabinoid we want, right? So after a few days of synthesis, the soybeans will be pressed for oil and extracted, right? And then, and then they can be purified from the oil, essentially by the same process that's used now in the cannabis industry, right? So then we'll take those pure cannabinoids and then we'll sell them directly to manufacturers for products such as edibles, for instance, right? Okay, so you must be thinking, okay, is this really possible, right? And so when we started this, we first wondered if soybeans could make CBD, right? And an audacious goal to say the least, right? And so my first hurdle was, who would even consider trying this? Well, turns out, former student of mine, now co-founder Simon Kalmus is that person, right? And after 3 years of hard work in the lab, well, here we are, CBD that was produced by a soybean, okay? So above is the full complement of cannabinoids that you would find in the cannabis flower by mass spec analysis, right? Below is the acidic form of CBD produced by soybeans in our lab, right? So, and it turns out we are the first researchers to successfully produce any cannabinoid in a plant other than cannabis. Okay, so now while we were the first to successfully engineer another plant to make cannabinoids, a handful of well-funded biotech companies have engineered baker's yeast to do something very similar. So what they've been able to do is bring the low-value precursor cannabinoid called CBG to market. And so, despite hundreds of millions of combined investment dollars, they have not been able to bring any final high value cannabinoids such as CBD or THC to market. And since they're all using the same organism, yeast, as their platform, it's time for a radically new approach. Okay, so based on the success of our CBD results, we're currently working on the first product that we want to bring to market. It's called THCV, right? Okay, so THCV is much like THC, but initial studies show that it increases focus and decreases appetite. Okay, so this is an alternative to THC that doesn't give you the munchies, otherwise known as diet weed. Okay, so and because cannabis only has trace amounts of THCV, the top edible producer in the country told us that the demand for this product is not being satisfied, right? So you just can't make it in cannabis in high enough levels for production. Okay, so here's our estimate unit cost analysis per acre of soybeans. If we were able to replicate the current yield that we now have for CBD with THCV, because THCV is currently going for $60,000 per kilogram, the cost of farming of soybeans is relatively low. Therefore, we expect a 70% return. And we're not stopping with cannabinoids. I mentioned squalene with a $112 million market, taxidiene with a $4.5 billion market. And we're also working on milk proteins and therapeutics known as biologics, and they represent a combined market of $1 trillion. And to be clear, I'm not talking about soy milk here. Okay, so these are soybeans that will produce cow milk, right? And the DNA is being assembled for each of these soybean varieties as I speak. Okay, so we're currently in our first phase of bringing THCV to market on a pilot scale. Phase 2 will be scaling up THCV production and bringing the other products online, such as the milk proteins and squalene. And then phase 3 will be our ultimate goal of farming and sustainable manufacturing of all the various products and therapies I've told you about today. So here, once again, I'm Brian DeDecker, and shown here with some healthy soybean plants on our family farm. So my professional background has been in research and teaching in academic institutions here and abroad. This is Simon Kalmus, my former student from the engineering department here at CU. He has not only been a part of every imaginative idea that you've seen here today, he's actually the one in the lab making them real. Now for our ask. For 800K, we're planning to bring THCV to market with our initial pilot program. And we expect this to take 18 months. And the most exciting part of this phase will be building our team, right? So it's been a lot of fun so far, for sure. And I'm looking forward to sharing this experience with others. And I can't wait to collaborate with additional researchers that we bring onto our team and learn from investors with experience outside of research. So anyway, continuing to turn this audacious idea into a reality is it's going to be an incredible journey. And thank you.
Thanks, Brian. Yeah. So yeah, I want to open it up to questions. Anyone has any questions, please put those in the chat. And we have our first one here from Joey Money. Can you explain further how you can take a dried plant and turn on the genetic switch to produce the desired product?
Oh, well, yeah, that's the beauty of our method. We're going to germinate the beans, right? So that's the beauty of beans. You can turn them on with a little water. So there you go. And then we also have genetic switches built in that will turn on the molecular machinery that we engineered into them.
Okay.
And that's all a method that we patented under the university.
So next question, are there any potential environmental risks when growing these altered soybeans in open fields? What can you do with the leftover soybeans once the substance is extracted?
Right, so as I mentioned earlier, the soybeans themselves are not going to be producing any of these products while in the field. They will contain, extra genetic DNA information in them, but that's no different than 99.9% of the beans being farmed now. Basically every bean in the field now has been genetically engineered for like herbicide resistance, right? Which is actually, don't get me going here, but unfortunately that was the first real big example of genetic engineering, was to make plants more resistant to herbicide. It really wasn't a good example of the power of this technology, but it is what it is. And my point is, it's no different than the soybeans out there now as far as genetic engineering goes. And what was the second part of that question again?
What can you do with the leftover soybeans once the substance is extracted?
Probably depends on the substance. So for the cannabinoids, if the extracted material will be, biomaterial that you would get from, the same sort of leftover you would get from oil extraction from the soybeans. If it has, trace amounts of CBD in it, I don't know. I think they're feeding it to dogs now for the therapeutic dog foods. So maybe that'll be, if it has something more in it, a little more potent like THCV, it might have to be careful. If it's the milk proteins and things of that nature, that you could probably treat as you would any sort of any product that you would feed to animals. But ironically, the milk, the milk protein project would hopefully eliminate the need for many cows, right? So maybe hopefully there's less cows actually to feed with that leftover product, if that makes sense.
Okay. Next question is, could you talk a little bit more about your go-to-market strategy? Who would actually be farming it, and who would be the early adopters that are purchasing these farmed products and processing?
Right. So with the THCV, since the markup is so huge on that, that's why we picked that as our first product. We're actually planning on growing that in Colorado with greenhouses. So we've calculated we could probably get early decent revenues just by growing that in greenhouses here. And then of course the later phases will be like back in the Midwest where I'm from, and those will be contract farmers. And the model there. So I've actually talked to actually the business people who manage our farm. There's basically a model that like seed companies now use where they contract farmers to grow seeds at a premium, and then the seeds have to be brought back to the, for instance, to the seed companies. And we have that same sort of model, if that makes sense. And then, like I said, we've done some market research, and the leading edible manufacturer that's actually here in town, they're the ones that gave us the market research, said you got to make the THCV to start with, right? And so basically edible manufacturers would be our first markets for THCV.
We had another question about genetic modification and some of the stigma around that, and if that's a concern for you.
Yeah, that's an interesting question. It probably depends on the product. And here, so let me give you an example. For the therapies and medicines, probably not so much. Like, does anyone care that your aspirin doesn't come from bark anymore, right? I'll give you another example, insulin, right? So insulin, and this is actually the first example for synthetic biology. Insulin was first extracted from dog pancreases, right? And that was the first life-saving medicines for children with type 1 diabetes, right? In the early 70s, they engineered they engineered E. coli bacteria to synthesize insulin, right? So that was actually the first example of genetic engineering. I don't see a huge clamoring now to go back to, dog extractions for natural. Oh, I think my dog heard that. It's okay. So I don't think, there's a huge clamoring to go back to dogs for that production, right? Now for the milk, that's probably going to be trickier. And I think people, are a little more sensitive about foods and such. Let me be very clear, this is completely safe, this technology, but the perception of that may not be so, right? And so with that, it's going to be interesting because the yeast people are bringing some milk proteins online right now to the market. So we're going to be watching that with very carefully. For instance, I think some of the creamers at Starbucks are going to be yeast based, right? So some of those transgenic milk proteins are going to come online very soon. So we'll see what the reaction to those are. But once again, we can say they're not. We're eliminating cruelty to cows, which is a real thing, right? So I think we have a good argument on our side.
Okay, you are at time, and we are at the point in our schedule where we are going to take a break. So we will reconvene at Sorry, I'm just trying to get to the schedule here. At 1:35, so we'll be taking a 15-minute break here. So I will throw a timer up here on the screen, and we'll be reconvening here at 1:35. So thanks everyone that's pitched so far and contributing. Yeah, no, I will be putting the schedule and the timer back up. Let me just do that. Yeah, thanks for everyone that's presented so far, and all the questions in the chat. We really appreciate it. Okay, and there is the schedule. So I will be great. Apologize. Yeah, I'll put the timer up there. Feel free to take a break. I'll get this sorted out when I'm not trying to talk.
Thank you so much.
Does not want to cooperate with me. Okay. Hi everyone. We're gonna get rolling again here with amplified space. Just to go over where we are in the schedule. We just had a break. We have two more teams to go, and then a quick wrap up. So appreciate everyone for sticking around. I'd just like to remind everyone to make sure that they have their mics muted. Our next team is Amplified Space, and you're gonna be hearing from Jerome about his innovative new company that's going to remake the way that satellites are designed and manufactured. So with that, if Jerome is back on here and ready to go, I will kick it off to him and let him share his screen.
Yep, I'm here. Let's get the cool. First, thanks Venture Partners for giving me this opportunity. It's been a real fun trip. I've been through 3 programs now, and it's always been top notch and very helpful for me, a technical founder, trying to find the business acumen as quickly as possible. So I appreciate that. Okay, so here we go. My name is Jerome Hiddle. I'm founder and CEO of Amplified Space. At Amplified Space, we're reducing spacecraft development timelines from 24 months to 1 using smart power systems. We essentially want our engineers testing more of their spacecraft, gaining confidence in their spacecraft so that when they go to ship it, they know it'll work, and also designing their spacecraft a whole lot less. And with our smart power systems, they can easily configure the spacecraft in whatever way they can imagine. And so when we look at all 3 of these spacecraft, they're all visually different, but internally they're different. And specifically, their power systems are built using very old school analog techniques. They're hard to adjust, they're hard to modify. Even when you do use a power system that's every one of these I've done, there's always been a power system that needs changed in here. And so we're adding some digital techniques to be able to make the analog portion of the power system as adjustable and configurable as possible. And we're doing this using our embedded technique of a software-defined power controller, which takes hardware and software together and makes it to where you can connect whatever solar arrays and batteries you want based on what you have currently in stock. And then you can pair those with the current stock you have of your payloads, and so that you can simply imagine a spacecraft, imagine your mission, and assemble the spacecraft kind of like Legos and fly the spacecraft. And by doing that, you can ship much more product through the door. We do have some competitors, but none of them do the digital control. Some of them have limited capabilities to make changes, but none of them have our wide range of ability to change a lot of things. And this has been confirmed by NASA. They call our technology the first of its kind, and they also say we have a significant value prop. Speaking of NASA, we completed a small business innovation and research program with them, where we delivered a working prototype on time and on budget. We've also been selected by CU's Ralphie mission to provide the power system for that spacecraft. This will be our first flight, our first sale, our first real customer feedback to find out what people liked and what they didn't like about what we're doing. And it's also worth mentioning that it'll get our eyes in front of the Air Force, because this project is funded by the Air Force and they are aware of our technology. So our business models start with nano satellites, prove the technology and establish that customer trust. These satellites are about the size of a shoebox, and there's many of them go up, and many of them can take additional risk of proving that new technology. And then we also will be able to take what we're currently developing and put them in parallel into a little bit larger spacecraft and go ahead and ship those as well. We also want to get into large satellites, and our technology is scalable to radiation hardened platform so that we can enable the real high cost, high value spacecraft to also have this technology. Finally, the John Deere model. John Deere sells tractors and they make some money on tractors, but guess what? Their real money is in the data as a service, the data that's incorporated with how much yield the tractor's getting. And so we're looking at doing the same sort of things in our product as well. The satellite industry is growing immensely. We're looking at about 2,500 spacecraft flown next year. And the market therein is growing from about 190 billion last year to 240 billion next year. And specifically the power system market to design these power systems is about 0.6 billion and is expected to grow to 1.3 billion. And that represents about 17.2% CAGR. Total spacecraft flown in 2026 is projected to be 4,700 spacecraft, and we're looking to sell almost 400 of ours, which is roughly about 8% of the market, and capturing about $37.5 million in revenue. We're currently asking for a $1 million raise. This is mostly to help with finding the proper people to be able to show NASA and the Air Force that we have the right people and the access to capital to be able to raise that $1.5 million in non-dilutive funding right above it. By the end of 2026, we're looking at about $30 million in profit, and with that, that's also before taxes and reinvestment into the company. It's also worth noting at this point, the technology that we're doing is actually technology that can go into several verticals within aerospace and even into terrestrial markets as well. So we're exploring those. I think one of the big things with the fundraise is getting the right business person in here with good experience to be able to help solve those problems of what verticals and when. I've been doing this for about 15 years. I actually designed NASA's InSight charge controller. I have 2 US patents. Eric's been working in the disk drive industry and is a mixed signal expert. He's been doing all our software and firmware development. And I just learned last week that Josh Yang's going to join the team. I've been working with him for about a year, advising at the University of South Alabama, who's doing a project with the University of Colorado. So it's been really nice to work with him, and he's agreed to come here. He's actually turned down an offer from Tesla to come here. So very excited to have him, and we have just a great board of advisors, and we're really happy to have them all, and I can go into greater detail about each of them if you'd like. So now that you've met the team, join us as we create disruptive technology to allow our customers to ship more spacecraft and for our engineers to be much more productive. And with that, I will answer any questions you may have.
Okay, I want to encourage everyone to drop their questions for Jerome in the chat. Jerome, did I miss? Did you have an ask? Are you currently in a fundraising round? So just to start it off.
Yeah, we're looking for about $1 million, mostly to help provide salaries for some high-level individuals.
Okay.
And when we do that, we've actually gotten feedback from NASA that we lack capital and lack personnel to execute. And so I found myself in a catch-22 of the people that I really need don't want to come work here without a good salary. So I'm offering them salary instead of equity in the company.
Okay, so Bill Jeffrey would like to hear a little bit more about specifically what your IP is and how that creates a moat around the technology and prevents others from entering with a similar technology.
So we do have a provisional patent filed, and our technology is the marriage of the analog and the digital portions of a power system to be able to configure the power system basically any way you'd really like to, as your heart desires.
Do you have any idea of specific claims that you're looking for and how those would protect
My patent attorney is working on the specific claims right now, and I'm more than welcome to discuss that on one-on-one.
Okay. Tim Jones would like to know, of the 37 million in revenue in 2026, what portion of that will be recurring? Are these, I think what he's looking to know is, yeah, are these just one-off flights, or is this a continuing relationship with that? And a follow-on question to that that's very similar is, are you selling design services or hardware?
Good questions. This is a recurring revenue stream. And as we gain more customers, it's looking to grow. Every satellite that's shipped has to have a power supply. And so every time there's a flight made, there's another power supply go up. And yeah, so that's good. Right now, we're not looking so much to do services, although we are looking to do some services just as a revenue stream for the company to kind of keep us solvent in the early stages. But long term, I don't see us as a service, more as a product development with these specific products.
Would the software to control the power supply, would that be included in the original purchase price of the device, or would that be a recurring software license? If there's a 10-year lifespan on a satellite, is there going to be revenue coming in for the software to control your power supply?
Right now, what we're looking at is that the basic software comes with the purchase of the power system. However, there might be data that the power system collects that's additional software service.
So Sally's clarifying her question a little bit. Do you design and deliver the actual power supply? I'm not clear on if you have to actually build the power supply.
Yes, we're actually building the power supply. And so this is both a hardware and a software solution. It's an embedded solution. And so to marry those two together, they have to be pretty well communicative between the two. And so we provide a hardware solution, and then there's some software that we also provide with that so that people can execute whatever power system they want.
So when you said that you delivered a working prototype to NASA, that was a hardware power supply that was fully functional?
It was a hardware power supply with the software able to reconfigure it on the fly. Yep.
Okay, and you'll be manufacturing this power supply for the Ralphie mission. Is there any hurdles on the actual manufacturing supply chain or expertise that you need in order to get your first mission in space?
I think we've got a really good plan. The actual mission isn't scheduled to go till 2025, so there's plenty of time to kind of work on that. We do have our first delivery here before the end of the year, however. And so in order to do that, we have pre-purchased a lot of the parts, and we're currently talking to manufacturers of circuit boards to have somebody else manufacture it and then us test it in-house.
Okay, I think with that, you're at time, so we're going to cut that off. And thank you for presenting, Jerome.
Cool. Thanks, everybody.
Okay, we have one last team here for you today, and that is Simon from Latimer Controls. And not to say we saved the best for last, but it's a pretty exciting technology. Sorry, Jerome. No, Simon's got a really exciting technology. I think you'll be glad you stuck around to hear this presentation. So with that, Simon, if you want to kick it off.
Awesome, thank you so much. Yeah, and likewise with everyone else, thank you so much to the Ascent program. You guys have provided amazing resources. I myself also, as a technical founder, really appreciate the external support from you guys and the team and everyone else. So thank you. Let me minimize myself here. I don't need to be looking at me. Okay. Oh. Okay. Thank you so much for coming. I'd like to look back at Thomas Edison and his invention of the light bulb. However, not many know that it was actually an under-recognized Black inventor named Lewis Latimer that took this invention of the light bulb from a useful marvel of science to a dominant and scalable technology that we saw in our everyday lives. That's exactly what we're looking to do here at Latimer Controls with solar on the power grid. My name is Simon Julian, and I actually just graduated with my graduate degree in engineering from the University of Colorado. And for the past 3.5 years, I've been working alongside the National Renewable Energy Lab and CU to develop this technology that we actually, with venture partners' help, just filed an international patent on, to allow, as a software, to allow solar to mimic and therefore hopefully replace fossil fuels on the power grid. So with solar technology today, it is not controllable or scalable to the point where it can dominate energy resources on the power grid. And this is due to the partial shading events that you see right here that cause very high variability in power output from these solar power plants. With our technology, we're able to identify which panels in this power grid are being impacted by this partial shading, intelligently signal to other power operators in this power plant to increase their production to maintain the stable and controllable energy that is necessary for replacing fossil fuels. To put it simply, we make solar smarter. Now, we are a very technical team, so we've had to put in a lot of effort in this Ascent Accelerator and a few others to really remove the engineering lobes from our brain for a second and look into the customer investigations, this competition analysis, etc. What we found as far as the customers is they are finding that it's becoming more and more profitable to not just inject all of your solar power at once, yet instead it's actually more valuable to be able to control the power output and help the grid with your power injection strategically. As far as competition, a lot of the innovation is being done in smart battery systems. However, if you talk to these industry leaders, they say that these batteries are too expensive to invest in today, and they're getting cheaper and cheaper and better every single year. So they don't want to make that investment right now. And there's the component that not all batteries are very sustainable themselves due to the mining of rare earth metals. So as validation, we found from both industry leaders and technical experts that our direct approach with a software solution to make solar smarter is actually what they are looking for in terms of being able to control this power output as they need for these advanced solar operations. And just to reiterate, we work with or without storage onto these solar systems. If you do integrate storage onto these systems, we have projected that you'll find about 52% savings because we're reducing the mileage that you are putting through this battery and charging and discharging and helping this instability from your solar power plants. And if you put us directly on the solar plant with no storage, you'll currently find about a 30% revenue increase by bidding into more complex grid markets. And that's only going to increase with more and more revenue as these markets transition to incentivize solar more and more, as you know, we hit these Biden projection goals of 2035 net zero power grid. So we have an amazing team and an even more exciting advisory team, actually. So these two doctors are my inventors and academic advisory team, including a chief scientist at the National Renewable Energy Lab and another professional researcher here at CU, Amir. And we've also had really great business support, the Ascent Accelerator through venture partners, 1,000 Greta's. We did the CU Catalyzed Accelerator, and we've been working very closely with the Deming Center of Entrepreneurship. So altogether, we have a very strong advisory team that's helping us really get to our goals here. So where are we right now? As I've mentioned, we've been putting in a lot, years and years of research. We've been applying to some very advanced grants. Some of other people have mentioned it, but one we're waiting to hear back in the next, month or so is the SBIR, along with some other grants that we're trying to raise right now with non-equity based funding. Alongside some partnerships, we've been talking closely to Excel Energy and a few other cool or local communities, local companies, to run their data on our simulated systems and show them how they could profit with these advanced controls on their solar power plants. Together with this grant funding and partnerships, we're looking to build a real MVP pilot in terms of a operational solar plant that is running by 2023. And that's where we're going to be able to launch and start raising outside capital. Our approach here, starting in 2022, well, it's 2022 now, making this MVP pilot in as a product of SaaS, software as a service with B2B sales. Once we get this launch going and we're going into real sales, we're going to be looking directly into what's called the developer ecosystem. And what this is these are companies that in new built out solar power plants, they're taking solar inverter manufacturers, engineer planners, power system operators, etc., and kind of as they're making this ecosystem to develop individual power plants. And we're hoping to integrate into these developer companies themselves. And so kind of a fifth product would be this software control for the solar panels. And with our interactions with Excel and maybe some other larger scale utilities, we are eventually looking to get these utility contracts where we're actually operating on multiple plants at a time. And this is where we are really excited, because actually down to the technology's core, we have developed this to not only work on solar where we are starting, but it actually will scale to battery storage, wind energy, rooftop solar, hydro, etc., to where we're not only operating single power plants, but we are actually operating a smart and renewable power system of the future. So thank you so much for listening. I'll take questions now. Thank you.
Okay, so got our first question in the chat here. Sorry, it says, why are utility contracts 5 years out? Does the sales cycle take that long? And how are you developing these partnerships to get those utility contracts signed in the future?
Yeah, that's a really good question. So one thing that people joke about in this industry is how slow utilities are, both in adoption of technology and in just their cycles of any sort of change. One really weird thing that is actually changing in terms of the actual structure of regulation is utilities don't make money from advanced technologies or adding these things right now. They actually just make money from using their old technology and these coal, natural gas. There's no real incentive to be integrating new technologies except for almost the societal push and the governing regulations of carbon footprint. But that's changing very quickly. You see in California, actually in Texas as well, where there are now incentives. So part of that 5-year benchmark is waiting for those to kind of sweep through the nation in terms of it's actually now profitable for these utilities to start integrating and investing into new renewable technologies. Additionally, we want to, so these solar plants, in terms of a technological standpoint, they're interfaced through what's called an inverter, which takes the energy that's created from the sun and synchronizes it with the needs of the grid. And these inverters are made by different inverter manufacturers. And one really important point, coming as a startup company, is being able to, almost be certified on each individual inverter. So we need to start at the point of these pilots and specific inverter manufacturers to be able to say that we are ready to work on, Enphase's plethora of inverters, which is commonly used. And then once we have kind of a list of inverters that we are certified on, then we can go to these utility scale operations and get that dominant sale there.
Okay. I had a question about the oh, we got another one in there. You don't need my questions. So why is this hard, and why wouldn't the inverter companies start doing this on their own?
Yeah, that's a great question. So I don't have a great slide necessarily for this, but the hard part about this is the mathematics. I guess this might be a good one. The mathematics and software development of controlling so many factors at once is why this is hard. And the inverter manufacturers are more hardware-based companies. There are smart inverters being made. However, with these internationally filed patents and the non-provisional patent that Venture Partners holds and has licensed back to us. I'm the lead inventor on this. These are all groundbreaking technologies that have been peer-reviewed and published and have risen a lot of excitement in this controls arena of being able to manage the instability of these, wind or cloud coverage, wind changes, and the needs of the grid in second by second resolutions is a very tough mathematical and optimization problem. And basically we hacked it. And that's where, this technology was born and these patents rose their excitement. There are a few direct competitors, which is a good and a bad sense. One exciting one for us that actually kind of dawned this idea in NREL itself, where I started. They launched a test power plant in Chile where they actually had operations of this type of software operation of the solar plant. So this was being ran, at a national lab level research. So it's not a common, mathematical ability to integrate this into, everyday inverter technology.
Great. So I have a question about your simulation.
Yeah.
How close to the completed project is that? So I mean, I'm assuming you're taking the same data that you would be getting from a power plant that's actually operating it, and your simulation can show, what it would be doing. How close is that to the real product?
Yeah, great question. So yeah, our method here is we actually take historical data, so say from last year, and then we inject it into our simulation in real time. So our simulation is actually operating as if it is happening today, but the data itself isn't collected today. It's collected from some time in history, probably about a year ago. As far as where our technology is at, we have all these models and simulations peer reviewed and pretty set in stone at this point. We were very confident in that factor. Where we're raising this money is to develop the technology to actually integrate into these inverters, which will transition our simulations from being, one technology, which is in Python, MATLAB, and some electrical simulation software, to a very high level, C++, microcontroller integrated software level. And so we have to transition, the language of our code basically to be able to talk with this hardware and these inverters. But as far as the simulations, they're pretty set in stone, very confident in them. They're showing very exciting results, and the data we're using is real data. So we're confident that we can make this transition. We're just excited to do so.
Okay, so yeah, you are confident that when you build a physical, like you're operating this on a physical, that you're going to get the same results that you're predicting.
Yeah.
Okay.
Yeah.
You did that through the peer-reviewed process and everything. So.
Yeah, absolutely.
Okay, Sally has a question. Can you describe your partnership with NREL? How can you leverage their networks to bring this to market?
Yeah, that's a great question. So how this started, going through my engineering degree, I started as an intern at NREL, kind of got thrown this project as, a back burner. And then, after multiple years of working on it, it actually turned into front end research that we ended up, patenting alongside C Venture Partners. There's kind of multiple holdings in terms of who own the technology, and we figured that out. But NREL has a great network. There aren't any national labs that are designated directly to renewable energy except for NREL, and they have a great office for community integration. So they actually have accelerators themselves, and they have strong outreach, and they do really good operations with taking in startup companies like ours or ones that we're interested in communicating with. And kind of pairing up companies. So we've been, deep talking to people within NREL. My advisor is a chief scientist at NREL, so we have great connections, and we've been utilizing that. And then just their network in terms of scientists and industry folk has led us to, land, these communications with Excel Energy and a few others that we've been talking to as well. So I'd say NREL is a very central and important place to have a groundbreaking technology, and it's been of great use.
Okay, thanks, Simon. And I think we're at time here, and we're gonna wrap it up here. But really appreciate you presenting, and thanks to everyone in the chat that has stuck around with us. We appreciate it, and hope you enjoyed the presentation. So with that, I'm gonna kick it over to Nicole to finish our wrap up.
Sure. All right. Thank you so much, Justin, and thank you so much, teams. Very excited to hear about these next generation companies coming up and taking over headlines on fancy magazines soon. Do we have any sort of general questions from the audience? I know we just have a few minutes left, but if there is any sort of anything about the program or to a sort of a specific general question, I know we have a day coming up tomorrow as well, but I just wanted to give a minute to have you all speak if there's anything particular. Nothing right now. So anyway, we do have the second part of demo day tomorrow. 6 teams will be presenting. So we're very excited for that. Same time as today, 12 to 2 o'clock p.m. Mountain time. So we hope that you can make it to then. And thank you so much, everyone, for listening in. We really appreciate it. And please do contact myself or Justin if you want to get in touch with the teams. We will be sending out sort of a summary with the recording after tomorrow when the events are over, so that everyone can connect with whoever you want to. But if there's anything in the interim, please do reach out to us. Otherwise, we wish you all a wonderful rest of the afternoon here, and really appreciate your time. Teams, thank you so much for great presentations. Audience, thank you so much for great questions and for your time today. We very much appreciate it. All right.